Now let's talk about how can we determine the sign of a trig function. And I mean the sign, not the sine. What? The sign of a trig function depends on the quadrant where the terminal side of the angle lies. And there's a nice way to remember it, a nice mnemonic. It goes like this. All sad turtles cry. I've never seen a turtle cry, but I'm just assuming that if turtles are sad, they cry too. And how does that help us? In quadrant 1, all means that all trigonometric functions are positive. S stands for sine. The sine and its reciprocal cosecant are positive. All the other ones, cosine, secant, tangent, and cotangent, are negative. The T indicates that the tangent and its reciprocal cotangent are positive. All the other ones are negative. And in our fourth quadrant, the C indicates that the cosine and its reciprocal, the secant, are positive. All the other ones are negative. And another way to think about it is also to just imagine a point on our unit circle, any point really with its coordinates x and y. And in quadrant 1, both those coordinates are positive. Now let's take that same point and reflect it over the y-axis. We get here, and here our x-coordinate is negative, our y-coordinate is positive. That means that the y-coordinate, which is the sine, and its reciprocal are going to be positive values, while anything that has to do with the x-coordinate, that's the cosine, that's the secant, and that's also tangent and cotangent who have it in their ratio, are going to be negative. Then if we reflect that point over the x-axis, we get down here, and in quadrant 3, both coordinates are negative, and that means that both cosine and sine and their reciprocals are negative. However, if you take the tangent and divide a negative number over a negative number, you get a positive number again, and the same is true for the cotangent. Last but not least, reflect the point back over the y-axis. You get a positive x-coordinate and a negative y-coordinate, and that means that the cosine and its reciprocal are positive. All the other ones that need the y-coordinate are going to be negative values. All sad turtles cry. Let's feel bad for the turtles, but feel good for ourselves because we have this mnemonic to help us out. Then let's see, how do we find all 6 trig functions if we're given 1 or maybe 2? In order to do this, we are going to take a look at our coordinate plane and think about what we just learned about the signs of the different functions. We have a tangent of theta, which is 4/3. That's the positive number. So the tangent has to lie somewhere either in the first coordinate or in the third. That's where tangent values are positive. And additionally, we are told that the sine of theta is a negative number. If the sine of theta is a negative number, that means that it's going to be either in the fourth quadrant or in the third quadrant. And basically now we need to look for our value in the quadrant that has both shadings. Let's do that. Let's take a new coordinate plane and let's think this through. We have a tangent that's 4/3, and our angle has to be in the third quadrant. Let's draw an angle. Angle theta. Tangent is the opposite over the adjacent. That means from angle theta, the opposite side is here, and that should be 4, and the adjacent should be 3. But since we are in the third quadrant, both numbers have to be negative. Taking two negatives and dividing them by each other gave us that positive value for the tangent. Now, in order to find the other trig functions, first we need to find the length of our hypotenuse. At this point, we're no longer in the unit circle. The hypotenuse does not have the length 1. Looking at two legs, you can either use the Pythagorean theorem or remember your Pythagorean triples. 3, 4, and 5 is one of them. So our hypotenuse has to have the length of 5. Then we can now write down our trigonometric functions. The sine of theta has to be equal to the opposite of the hypotenuse. That's negative 4 over 5. The cosine of theta is the adjacent over the hypotenuse, negative 3 over 5. And the tangent was given to us. Tangent of theta is 4 over 3. Now go ahead and stop the video and find the reciprocal values yourselves. I said stop the video. And here they are. Cosecant of theta is negative 5 over 4. The secant of theta is negative 5 over 3. And the cotangent of theta is 3 over 4. Let's do another one. Find all 6 trig functions given the sine of theta is negative 3/5 and the cosine of theta is 4/5. And first we're going to draw our coordinate plane again, and then we're going to determine where our angle lies. The sine of theta is negative. So where is the sine of theta negative? It's negative in the 3rd quadrant and in the 4th quadrant. And the cosine of theta is positive. Cosine of theta is positive in the 1st quadrant and then again in the 4th quadrant. That's where both overlap, and that has to be where our angle lies. Let's draw a fresh coordinate plane. Our angle is in the 4th quadrant, and we're always going to draw this angle with this leg going towards the x-axis. This is theta, and our sine is negative 3 over 5. That means that our y-coordinate is negative 3. We are in the 4th quadrant after all. Our hypotenuse is 5. The cosine is 4 over 5. That means that the adjacent side is 4. Now we have everything we need to write down all our trig functions. The sine of theta we were given is negative 3 over 5. The cosine of theta is 4 over 5. The tangent of theta has to be the opposite of the adjacent. That is going to be negative 3 over 4. And now go ahead, stop the video again, and find the reciprocal functions yourselves. The cosecant of theta is negative 5 over 3. The secant of theta is 5 over 4. And the cotangent of theta is negative 4 over 3. And on we move to our last example of the day. This one is a little different. We are only given the terminal sides of one point, and we have to find all 6 trig values. But we're going to start the same way again, drawing our coordinate plane and trying to figure out where that point lies. The x-coordinate is positive, the y-coordinate is negative. So we have an angle that lies in the 4th quadrant. This is our angle alpha. The x-coordinate is 8 and the y-coordinate is negative 15. So now we need to find the length of our hypotenuse. And how do we do that? Of course, with our Pythagorean Theorem. C squared is equal to a squared plus b squared. C squared is the hypotenuse, that's equal to 8 squared plus negative 15 squared. C squared is equal to 64 plus 225, and that is 289. Now we're taking the square root of both sides, and the square root of 289 happens to be 17. Alright, phew. And that's the length of our hypotenuse. And I'm going to have you stop the video one more time and find all the 6 trig values yourselves now, and then afterwards check your work with mine. I said stop the video. And here they are. The sine of alpha is opposite over hypotenuse, negative 15 over 17. Cosine of alpha is adjacent over hypotenuse, 8 over 17. Tangent of alpha is opposite over adjacent, negative 15 over 8. And our reciprocal functions are the cosecant of alpha is negative 17 over 15. Secant of alpha is 17 over 8. And the cotangent of alpha is negative 8 over 15. All right, you guys. That's it for today, and I will see you in class.